Hi, this video covers a number of easy to apply or practical solutions for your dry gas seal operation problems. So you won't have to call OEMs next time your compressor trips or you just can't start it. I'm Mohammed Sadatmand, rotating equipment engineer. I've been dealing with dry gas seals for the past 10 years or so. In fact, I've witnessed disassembly of over hundreds of them for contamination or mechanical failure reasons from all major OEMs. I've also dealt with many dry gas seal issues in the field. You name it, most likely I've dealt with it. And when I say I dealt with it, I don't mean I went to the site and looked at a few readings and suggested to replace it, like most OEMs do. I did everything conceivable not to change the seal and put the compressor back in operation safely. So here I am going to talk about 4 important topics. First, how does a dry gas seal fails? Second, those pesky pressure limits that trip the compressor. Third, what to do when a compressor is tripped or you can't start it because of a dry gas seal system. And fourth, what are the options if dry gas seal appears to have failed? Okay, how does a dry gas seal fails? Well, in general, I'd say there are 2 types of failures. One is when it is mechanically fractured, in which case you are dead in the water. And the other type is when it appears to be contaminated or leaking excessively and causes the machine to trip. Now, let's see how dry gas seal works and what generally causes mechanical failure of the seal and what causes excessive leakage. Here is a typical tandem dry gas seal. Clean gas enters upstream of the primary seal. Most of it goes back into the process side and the rest goes into the primary seal. What passes the primary seal, some goes to flare or primary vent, and the rest goes into the secondary seal, and then into the secondary vent. As you can see, the mating seal ring, the 2 red blocks, is locked to the compressor rotor. And you know the rotor continuously moves axially back and forth because of the thrust load or pressure changes. Now, stationary ring, the orange ones, are a kind of floating ring and are designed to follow the rotor to maintain that critical seal gap. As you can see, they are axially held in position by gas pressure balances and the springs behind them, and radially by the infamous dynamic seal ring. Now, when contaminants gets on the dynamic ring, or seal just wears out or disintegrates, then it creates a stick shape, and then the stationary ring is not free to move back and forth. Now, if it gets stuck in a closed position, then rubs hard against the mating ring and fractures very quickly because of friction. If mating ring fractures, then you'll see a sudden increase in vibration and change in primary vent pressure. But if a stationary ring fails, you'll see pressure changes for sure, but you may or may not see vibration changes. Now, if a stationary ring is stuck in an open position, which is often the case, then you will have a massive gas leak or a high or low vent pressure, depending on which seal is jammed. So majority, if not all of the dry gas seal issues revolves around the dynamic seal ring. What kind of sealing surface material you have or how complex the groove shape is are often irrelevant. Whether it's a diamond or silicon carbide or CFD generated 3-dimensional groove shape or just a simple groove, none of them would make any difference on how quickly dynamic ring jams. In fact, you could have your initials or your lover's initials grooved on the seal ring and it will work just as good. I am willing to bet my bottom dollar on that. So, dynamic seal ring is your angel and the devil. So you better select it wisely next time you choose your dry gas seal. Now, Some dynamic seals are more forgiving than others when it comes to contaminants. Some with high tolerances or compressor structure would make the seal less forgiving, and the slightest dirt will jam the seal. So a lot depends on the type of dynamic seal and the general design of the seal itself on how quickly a given dynamic seal gets jammed. In fact, I've had more issues with those fancy PTFE rings than those simple dynamic O-rings. Now you know how the seal works and what causes it not to work. Let's get back to the main issues. The primary vent pressure is too high or too low to operate the compressor, or compressor is tripped and cannot start it. Does it really mean you're dead in the water? Not really. Let's figure out what is really too high or what is really too low for primary vent pressure. Can we override the limits? Why pressure above 4 bar, for example, or below 1 bar would be unacceptable? What are the consequences if they are out of those limits? And who and how they arrived at those limits? And what are the science behind them? These are the $64,000 questions that often there is no proper or technically sound answers from OEMs. Usually they say experience-based or safety. And whenever safety is mentioned, there'll be no more questions. And there it goes, at least $150,000 for repair and 1 or 2 weeks of downtime and a huge loss of operation. Okay, now what kind of vent pressure would be totally unacceptable? Or how far can you confidently go above or below the limits? Well, it all depends on historical data. Like, was it a gradual change or a step change? Who is the OEM? What kind of instrumentation or access you have to the secondary vent? What type of buffer or tertiary seal you have? Is it air or nitrogen? And at what pressure? All would go towards making fact or data-based decision on should you change the limit and continue running or not. Of course, if you decide to change the limit, then you're going to have to adjust both, the higher and the lower limit, just to be on the safe side. Now let's say you've determined primary vent pressure readings are just unacceptable and is beyond changing the limits. Well, first, you're going to have to make sure it's not the seal itself. There are other parts that could easily affect the primary vent pressure, like clogged or dirty orifices or pressure control valves. Let's say you've checked everything else and still readings are way out. Does it really mean you have to yank it out? Not so fast. You have a couple of options that I've had pretty good success with them. The simplest one is to physically bump the rotor. Either mechanically lever it back and forth as much as thrust bearing would allow, or run it to some high speed and give it a fast shutdown. Do this, start and stop a few times. It's all about jolting the rotor so the dynamic ring will let go. This could free the seal if a dynamic ring is really not glued to the casing. Now, if the bumping didn't work, the next option is alcohol flushing. Yes, flush a few gallons of pressurized alcohol into the seal. About 10 bar of nitrogen would be ideal for this purpose. In fact, I've done this procedure many times with about 50% success rate. It all depends on the type of seal you have and how badly it's contaminated. You could be in luck, you never know. Now, how exactly you would do the flushing would depend on your seal type and the number of ports you have. First, you have to figure out which seal most likely is stuck, which port to pump the alcohol into the seal first, and which port or ports have open as vent. As you can see, there are 3 or 4 ports to push alcohol into a given cavity. And by closing 1 or 2 others would kind of force the alcohol to go in a certain direction. So yes, there are many ways to skin this cat. There's a right way that would save your seal, and there is ineffective way that you will have to yank out the seal. So knowing the ins and outs of the seal and plenty of experiences with this procedure will go a long way. You can actually do this procedure for about 3 to 5 hours depending on your setup. And I wouldn't call the OEM and ask them for a flushing procedure. I doubt there is one, and I highly doubt any OEM would even recommend that. It's not to their best interest, is it? Okay, alcohol flushing didn't dislodge the seal. Now what? Call OEM? Not so fast. Most of you guys have tooling to remove the seal, right? Get the booger out and have a good look. And if there is no obvious sign of mechanical damages or fractures, then take it somewhere nice and clean to open it up. All you would need is a few Allen keys, a few long screws, a few soft blocks, and a soft hammer to take it apart. There is no magic into it. You'll need some cleaning liquid like alcohol or electronic instrument cleaner to clean all the parts and put them back together. In most cases, you wouldn't need to replace anything. I wouldn't worry about a few light scratches on the ceiling faces. Only deep cracks are of concern. The only part you need to be really careful about is the dynamic seal ring. And even that would need an eagle eye or an experienced person to decide if it's usable or not. Or just to be on a safe side, buy a spare dynamic seal ring and just replace it regardless. And put the seal back together and off you go. Well, there are way too many field issues to discuss on dry gas seals, like high gas content and secondary vent, which is often used as a ways and means of evaluating which seal is failed. Leakage or flow rate from or into the seal, crude oil contamination, or lube oil migration, and so on. Way beyond the purpose of this video, unfortunately. But I hope you find this information useful or at least informative. And good luck dealing with your dry gas seal issues. Remember, you can always contact me if you need support with your dry gas seal issues, or you just want to make sure that if you are making a sound decision to run the compressor or not run the compressor. Or maybe you just want to evaluate your compressor dry gas seal systems to make sure everything is handy dandy. That's it. Thanks a lot for watching this video. If you like it, please forward it to others and give it a thumbs up. And you can always comment below. Love to hear your thoughts. Thank you.